At first glance, these soft beige shirts look ordinary. But their story begins with rough coconut husks that are often treated as agricultural waste. Inside a modern processing facility, these heavy husks are opened, cleaned, softened, blended, spun, knitted, cut, and assembled into a completely different material. The transformation is possible only because coarse coconut fiber is carefully refined before it reaches the textile line. Truckloads of dry coconut husks first arrive at the receiving area. Each batch is weighed and checked before entering production. Large rotating drums loosen sand, dust, and loose debris while clean water sprays wash the uneven outer surfaces from every direction. Workers remove damaged husks and foreign objects, so only suitable material continues toward fiber extraction. The selected husks then move through a soaking system, where moisture begins loosening the natural material that holds the fiber bundles together. Traditional retting can take a long time, but modern controlled treatment can prepare the husks much faster. Once softened, the husks pass between hydraulic rollers that crack their rigid structure while preserving the longer fibers inside. The open husks enter a decorticator. Fast-rotating beaters separate the tough brown core fibers from the lighter, cork-like coconut pith. Airflow and vibrating screens then divide the two materials. The pith is collected separately and can be processed for horticultural products. Meanwhile, the stronger fibers continue along the main production line. At this stage, the coir is still rough, thick, and too stiff for comfortable clothing. It must go through several refinement stages before it can be used in a textile blend. Repeated washing removes dust and soluble impurities. Opening drums break dense fiber bundles into smaller tufts, while mechanical combs separate tangled strands and remove short fragments. The longer fibers are then arranged into a more uniform layer before entering a controlled softening bath. This treatment helps reduce stiffness and removes part of the material surrounding the fiber's cellulose structure. The process must be carefully controlled. If the treatment is too weak, the fiber remains rigid. If it is too aggressive, the strands may lose too much strength. After softening, the fibers pass through several rinse tanks. Clean water removes loosened impurities and any remaining processing solution. A mild neutralization stage stabilizes the material before one final rinse completes the wet treatment. Wide rubber-coated rollers squeeze out most of the water and form the damp fibers into a thin, even sheet. The material then enters a long drying chamber, where warm filtered air gradually reduces moisture without scorching the natural strands. Sensors inspect the exiting fibers. Any section that remains too wet is automatically redirected through the drying system. The dried fiber is now lighter, softer, and more flexible than the original coir. However, washing and drying can compress the material, so fine opening machines separate it again while suction systems remove the last traces of dust. The clean fibers then pass through carding rollers covered with thousands of fine metallic points. These rollers arrange the fibers into a thin, consistent web. Because coconut fiber is naturally coarser than conventional apparel fiber, only carefully controlled portions are selected for the clothing blend. Laboratory technicians test samples for fiber length, moisture, flexibility, and cleanliness. Approved material is weighed into equal batches, compressed into rectangular bales, and protected from contamination. With extraction and softening complete, the prepared core bales move to the textile department. Here, pale coconut fiber and clean white cotton are opened separately. Automatic feeders release controlled quantities of both materials onto the same production line. The fibers enter large blending chambers, where rotating paddles repeatedly lift, mix, and release them. Slowly, the pale coir and white cotton form one consistent, warm off-white mixture. The blended material then enters a carding line. Rotating cylinders straighten the fibers, remove loose particles, and form a continuous soft web. This web is gathered into a thick, untwisted strand called a sliver. Several slivers are combined and drawn together, improving uniformity and reducing thick or thin areas that could weaken the final yarn. Drawing rollers stretch and align the fibers. The refined strand then enters a roving frame, where a small amount of twist gives it enough strength for spinning. High-speed spinning frames pull the roving to its final thickness and add controlled twist. This locks the coconut and cotton fibers together to create a stable light beige yarn. Electronic sensors monitor every strand. If a break or irregular section appears, the affected spinning position stops automatically while the rest of the machine continues. The finished yarn is wound onto large cones. Automated cleaners remove sections that fall outside the approved thickness range. Before knitting begins, samples are tested for strength, consistency, and resistance to abrasion. Weak yarn could break repeatedly inside the knitting machines, so only approved cones move forward. The cones are mounted above circular knitting machines. Dozens of yarn strands feed into rapidly moving needle systems. Thousands of needles form interlocking loops, turning the blended yarn into a continuous tube of soft beige knitted fabric. Operators monitor yarn tension and check the fabric surface as it collects beneath each machine. The knitted material is then opened into flat sheets, washed, and treated with a mild finishing formula to improve softness. Controlled drying relaxes the knitted structure. Compacting rollers stabilize the fabric's dimensions and create a smoother, more even surface. Bright inspection tables reveal holes, stains, thick areas, or knitting faults before the fabric can enter garment production. Accepted fabric is rolled carefully and organized by batch. Computerized pattern software then arranges shirt fronts, backs, sleeves, collars, and binding pieces in a layout designed to reduce waste. Several layers of beige fabric are spread across a long cutting table. An automated cutting head follows the digital pattern and slices through the stacked material with consistent accuracy. The cut components are separated into complete garment bundles. Each bundle contains the front, back, sleeves, collar, and matching finishing pieces needed for one shirt. Adult male sewing operators assemble the garments. Shoulder and side seams are joined, sleeves are attached, and the crew neckline is completed. Overlock machines enclose the raw fabric edges, preventing fraying and creating a clean, durable finish inside each shirt. Loose threads are trimmed, and every seam is inspected. Garments with visible defects are removed before the shirts reach final pressing. Controlled steam and pressure smooth the fabric, shape the seams, and give every completed shirt a consistent presentation. Final inspectors check measurements, stitching, fabric appearance, and surface quality. Approved shirts move to automatic folding and packaging. Each shirt is folded around a simple insert, placed inside clear protective packaging, and packed into plain shipping cartons. What began as a rigid coconut husk now leaves the factory as a soft blended garment. Through careful cleaning, fiber treatment, spinning, knitting, and garment production, an overlooked agricultural material becomes part of a completely new product.